Hey everybody, so today I'm going to talk about energy flow through an ecosystem. So this PowerPoint is going to talk about where does energy come from, how does it move through an ecosystem, and how does it move through the trophic levels, and all that kind of stuff. So I'll talk about what trophic levels are here in a second. So we're talking about the energy on Earth, and all the energy on Earth is going to ultimately come from the sun. So if you think about it, we eat other animals, we eat plants. Plants derive their energy from the sun by doing photosynthesis, and other animals are eating plants, and those plants are deriving their energy from the sun. So plants are going to use solar energy to create glucose through a process known as photosynthesis. And we talked about photosynthesis in class when we talked about the carbon cycle. So plants that produce their own food are known as autotrophs or autotrophs, whatever you want to say, however you want to say that. And remember, photosynthesis is going to use CO2 and water to create glucose and O2, and then we breathe in the O2. Alright, so here is photosynthesis. Photosynthesis is going to be where we have this CO2 and water, and the energy here is going to be in the form of solar energy. Alright, this is supposed to be an arrow, and it goes C6H12O6. This is glucose and 6O2, so it's producing oxygen gas. Alright, so plants and animals use glucose that they've created by plants to grow and perform life tasks. So plants are doing photosynthesis and cellular respiration. So cellular respiration is the opposite of photosynthesis. It's where you have the glucose here plus oxygen, and you metabolize it or you burn it, and that's how you get CO2 and water. Alright, so this is cellular respiration. So again, we've got this glucose plus O2 is going to form 6CO2, water, and energy. And energy is going to be in the form of whatever you're trying to do. Animals and plants both use glucose, so animals and plants are both doing this cellular respiration. And remember, fungi are also doing this as well. Remember, fungi or fungus cannot do photosynthesis. I don't know how many times I have to say it, but fungus does not do photosynthesis. So during the day, plants go through photosynthesis. At night, or also sometimes during the day, they do respiration to do things like grow and move their roots through the soil, and other things like that. So in this equation here, this is called sometimes cellular respiration or aerobic respiration. They're the same thing because they're taking place in the presence of oxygen. But what happens if you're trying to do anaerobic respiration, which is basically respiration that is not in the presence of oxygen? So this is called fermentation, and it's breaking down glucose in the absence of oxygen. So if you have an area that is a reducing environment, like a wetland or a soil that has been waterlogged, then you're going to have this fermentation process occurring. Methane can be created from CO2, this ethyl alcohol or ethanol. Acetic acid is also known as vinegar, and hydrogen sulfide. So all of these different things can be created when anaerobic respiration occurs. So only specific organisms can do anaerobic respiration. Humans can do anaerobic respiration, like in our muscles, but you can't do it for long periods of time because you're going to build up that lactic acid. Mostly decomposers are doing this, and so the difference between anaerobic respiration and aerobic or cellular respiration is there oxygen available? Alright, so let's talk about energy flow through an ecosystem. So the first thing that we're going to talk about are producers, or these autotrophs or autotrophs. So sometimes you may see producers listed as primary producers. So primary producers are going to be things that can produce or make their own food. So we've got plants, algae, phytoplankton. Those are all things that can take in energy from the sun, undergo photosynthesis, and create their own food. Organisms that don't make their own food and have to eat other organisms are called heterotrophs, or consumers. And there's many different kinds of consumers, which I'm going to talk about here in a second. All right. So whenever we are moving from one trophic level to another, and trophic levels are just like the levels of a food chain. So as we go up from one to the next, we lose about 90% of the energy as heat. And sometimes you may see heat being referred to as trash energy. So whenever you put off heat, we're not doing anything with that heat, are we? We're just, putting it off as a byproduct, as trash energy. So the remaining 10% can still be harnessed to do daily tasks. So as you move from one trophic level to another, you're losing 90%, or you're only retaining about 10%. So they love to ask questions about this on the AP exam. So they'll say, like, it starts out with, 20,000 calories down here at the very bottom of the food chain. And then as you go up through the trophic levels, they'll ask you, okay, well, how much energy is at the next level? And what they want you to do is they want you to take 10% of that 20,000 that they gave you, and then move that to the next trophic level. And then take 10% of that, and then 10% of that, until you get to the very top. And as you probably can guess, there's not a lot of energy left over at the top when you get to the top. Alright, so here are the various types of consumers, and whoops, I should have deleted these pictures. So it says a consumer that directly consumes plants or primary producers are called primary consumers. Alright, and the example of this one that I have here is the rat. I think his name is Remy from Ratatouille. A consumer that consumes a primary consumer is called a secondary consumer. So this snake here, if he eats the rat from Ratatouille, then he's going to be a secondary consumer. This rat from Ratatouille is eating acorns or something from this tree. Maybe it's eating some grass or something. And then finally, we've got a consumer that consumes a secondary consumer is going to be called a tertiary consumer. So this hawk here, this hawk is going to eat this snake that ate this rat, and then the rat ate the grass or the acorns or whatever. So it's called a tertiary consumer. Sometimes you may see one level higher than the tertiary consumer, and they'll call it a quaternary consumer. And the quaternary consumer is just going to be something that eats this hawk, which there aren't a lot of quaternary consumers. Alright, so here are some definitions for consumers, and you've probably seen these before. So an herbivore or a herbivore is a plant eater. They feed directly on primary producers. Then we've got carnivores, omnivores, scavengers, detritivores, and then decomposers. So these detritivores, they are feeding on like parts of the dead animals or dead organisms. So they're eating mainly detritus. Scavengers are things like turkey vultures or vultures that are just eating dead and decaying stuff, which is pretty disgusting. An example of an omnivore would be a bear or humans. An example of a carnivore would be like a tiger or a lion. And then an herbivore example would be like a rabbit. Decomposers are really important because they're recycling matter and they're recycling those nutrients. So when we talked about the nutrient cycles, we talked about how there are only a certain amount of nutrients available on the earth. And as you use up some of them, or as you take them out of the environment and put them into your body, there has to be some way for them to go back into the environment. And that's how this happens with these decomposers. Alright, so let's talk about some decomposers. They are really important because they are responsible for recycling nutrients. And what they mainly do, most of them are bacteria and fungi. What they mainly do is they release these simple organic compounds into the soil and water, and then they just kind of absorb them. So what this is showing here, this is showing some mushrooms that are living on a, it looks like it might be it's a mushroom. They're living on the side of this log that's fallen down. And what they're actually doing is the mushroom is the fruiting body of the fungus. So the mushroom is kind of like the flower of the fungus. And what the fungus is doing is it's secreting these enzymes, these hydrolytic enzymes that have a really, really low pH. And with a really, really low pH, it starts to eat away at stuff. And what they do is they break down the organic compounds that are in the tree, and then they absorb them through these things called hyphae. And if you're interested, we can talk more about fungi later. I took a whole class about it. It was really interesting because they're so weird. Alright, so let's talk about a food chain. So a food chain, if you want to track the sequence or the flow of energy through a linear path, and that's going to be called a food chain. And they love to ask questions about these on the AP exam. So this is a primary producer. This would be a tree. It's taking in energy from the sun. Some of the heat is going to be lost. 90% of it's going to be lost as heat. And then this caterpillar's eating a leaf. Some heat is going to be lost. The bird eats the caterpillar. And then there's going to be some heat loss here. And then it's showing you the microbes in the soil are going to break down this bird when it dies. Okay? So here's an example. So it says the successive levels of one organism consuming another are called trophic levels. All right, so if we've got primary producers down here at the bottom, we've got some grass, we've got a white oak tree, maybe we've got a white-tailed deer at the next trophic level. So if these are primary producers, they're using the sun's energy to make their own food. These would be primary consumers because they're eating the primary producers. All right, so as we move from one level to another, we're losing 90% of the energy. We're only retaining 10% of it. So if there's like 10,000 calories of energy, and remember, a calorie is just a unit of energy. So if we've got 10,000 calories down here at the bottom, whenever we move here, we've only got 1,000 because there's only 10% being retained. And then if we've got 1,000 in this level, we're only going to have 100 here, and then we're going to have 1 calorie up here, which explains why this brown bear has to eat a ton of these foxes. Again, if there was something above this tertiary consumer, it would be called a quaternary consumer, but those are very, very rare. So again, we've got primary producers who produce their own food, primary consumers who eat the primary producers, secondary consumers who eat primary consumers, and then tertiary consumers who eat the secondary consumers. All right, so a more realistic way to view an energy flow through an ecosystem is to use this thing called a food web. And food webs are really, really complex. And it's basically you take a ton of different food webs and you just put them all together. All right, so here's an example of a food web. This is more realistic because you've got the plants down here at the bottom, and you've got these different primary consumers that can all eat the plants. And then the fox here, he can eat the rabbit, he can eat the squirrel, he can eat the mouse, he can eat all of these different things. So this is kind of more realistic than a one single flow of energy through an ecosystem. All right, and that is my last slide. I finished this video in under 15 minutes. I hope that you enjoyed this video. If you have any questions, please give me a comment on Google Classroom, or you can send me an email. I hope you have a great day.